Greetings to you. We are starting our class with the determination of water parameter, drinking water parameters for arsenic. I will also take a look at some other methods that are there. Along with arsenic, some other parameters like chlorine and free chlorine, etc. In general, what we would like to say about arsenic is it is a carcinogenic element. Arsenic, there is lot of problem with arsenic 5, that is arsenic in valency 5. Arsenic 3 is not that bad, but in general arsenic whenever it is there in solution, it may get oxidized to arsenic 3 to arsenic 5. So, the danger of arsenic is always there. It is environmentally not considered safe at all, and it has basically no physiological role in the human metabolism or animal metabolism. Unfortunately, the arsenic has become part of our system already, even though it has no physiological role. That means it does not take part in any human metabolic processes. That means it is not an essential element, it is not a micronutrient, it is not an element that is present in large quantity, that should be present in large quantities also. So, unfortunately, evidence against arsenic has been piling up in the environment, and all over the world there is a general awareness of the dangers of arsenic in the environment. Arsenic is used in number of applications, including thin films, etc. It is also used as a food preservative, grain preservatives, and then it is used in paints, especially in marine paints. And in marine paints, what happens is the arsenic coating paint peels off, and then it enters the water, and then it is consumed by the fish and other marine animals. That disturbs the hormone ratio of male and female hormone ratio in all elements. So, the productivity of the fish and dolphins, etc., keeps on coming down, and there are a lot of accidents of arsenic also in the recorded in the history, recent history of about 30 to 50 years. Arsenic deaths have been reported, arsenic leakages have been reported, and recently in Pakistan 76 people have died due to arsenic. And in Manfredo, Italy, there was a huge arsenic accident, arsenic release basically, which rendered an area of about 110 kilometer useless for and they had to shut down all the human habitation and other livestock, etc., remove from the system. Even now there are traces of arsenic in and around, and arsenomolybdates and arsenic compounds, organoarsenic compounds have been there in use ever since last 50-60 years. And the most disturbing trend is even in India, arsenic is being found in drinking water, especially in Bengal, Bihar, that Dhanbad area, and nowadays in south also. For example, Dodballapur in Karnataka near Bangalore, many of the industrial estates, etc., are releasing arsenic knowingly or unknowingly in the waterways, and there seems to be a little problem with respect to arsenic in the drinking water. All over the world, the drinking water standard for arsenic is 0.01 ppm, that is about 1 nanogram. So, you can imagine what would be the demands on arsenic determination in the environment, in the air, as well as in the drinking water. Because even in if the arsenic enters in drinking water, it may lead to imposex problems, that is sex hormone ratio changing because of arsenic. So, there is a general awareness, and there is a requirement of the for the determination of arsenic in the environment as well as water. Now, basically arsenic occurs naturally, being 20th most it is the 20th most abundant element in the earth's crust. It is highly toxic and carcinogenic. It occurs as arsenite as well as arsenate, and the arsenate is +5 oxidation state. Safe level is 0.01 ppm. Following method, we have developed a method for the determination of arsenic using rhodamine B. Usually we have developed a method for the determination of arsenic using rhodamine B, that is a triphenyl methane dye, and in this method arsenate combines with the molybdate and rhodamine B to form arsenomolybdate, rhodamine B ion pair. The optimum pH is 4, that results in a color change from rose red to pink. The absorbance of the solution is usually measured at 595 nanometers, that is follows Beer-Lambert's law, and its the absorbance is proportional to the concentration of arsenic. Now, the reagents, the very simple, you can prepare stock arsenic 100 ppm by dissolving 41.7 milligram of disodium hydrogen arsenate in deionized water and make up to 100 ml. Then working solution would be 1 ppm, that is you have to dilute 100 times. It goes without saying that all the dilutions etc. in spectrophotometry should be done with very good quality water, that is the DM water of about 10⁻⁻18 micromole conductivity. That means very less dissolved salts also should be there. Now, you can prepare ammonium molybdate solution of 2%. For that you have to just dissolve ammonium molybdate that is available. It is available as a tetrahydrate in deionized water and dilute to 100 ml. Now, rhodamine B is a dye, usually it is available in kilogram quantities all over India. It is a cloth dye basically to make the colored to make the cloths look red and pink etc., but it is also a good chemical reagent, analytical reagent, that is available as a chemical available with chemical stores. And of course, when we buy from chemical stores, what we mean is it is available as a 99.99% purity. So, that is the idea of using rhodamine B. So, for that we have to you just have to dissolve 20 milligram of rhodamine B in deionized water and dilute to 100 ml. Now, the procedure is sodium, you also need sodium acetate and acetic acid buffer of pH 4, and for that you have to dissolve 1.5 ml of glacial acetic acid and 0.3742 gram of anhydrous sodium acetate in deionized water, make up to 250 ml. You have to adjust the pH to 4, and we have modified the earlier this method was worked for extraction. Now, we have modified with an aqueous finish. So, for that what we have done is we have dispensed with the organic extraction reagent, and we are recommending polyvinyl alcohol 0.1% as a stabilizer. So, ion pairs are normally stabilized using thick viscous solutions of polyvinyl alcohol, glycerol, glycol etc., and we have found that polyvinyl alcohol is fairly good reagent, and you have to just have to dissolve 0.1 gram in 100 ml, cool it, we have to heat it, otherwise it will not dissolve. So, what the idea is, you prepare 0.1 to 2.5 ml of the standard arsenic solution and add 1 ml of molybdate solution, add 2 ml of acetate buffer, and then you have to dilute it with 6 ml of deionized water and mix by swirling. Then you have to add 1 ml of rhodamine B followed by polyvinyl alcohol solution to stabilize the color. All you have to do is, remaining procedures are all fairly simple now. I do not have to tell you that you have to dilute it up to 10 ml and measure the absorbance against a blank. Again blank is necessary because it is also red in color, and as I have told you, molecular peaks normally overlap each other. So, the color of the blank must be subtracted from the color of the sample. So, you have to prepare a calibration curve, and it recommended sample volume can be up to 5 ml, because what we want to do is, we have to determine concentration of arsenic in 0.01 ppm. So, if you take 5 ml, 0.01 into 5 would be 0.05 micrograms of arsenic, and that will if you take a cookbook value 0.5 microgram of arsenic in 10 ml, that is 1 ppm, gives you an absorbance of about 0.1612 to 0.0 plus or minus 0.01 nanometer absorbance. So, this is the arsenic absorbance. Lambda, it is a fairly simple complex. This is drawn against the blank, and arsenic, the calibration curve is already here. You can see that up to 0.16 ppm you can determine arsenic. So, 0.1 would be somewhere here, but if you take larger quantities, you can make it come on the calibration curve. So, that completes our discussion on arsenic. Of course, there are other methods of determining arsenic by Marsh test, which is the conversion of arsenic into arsenic hydride, and that arsenic hydride can be dissolved in water and then treated with a triphenyl methane dye with a spectrophotometric finish at ppb level. So, there are several methods, but for the time being we are recommending this. If this method does not work because of the combinations etc., then you will have to look at arsenic hydride method. Okay. Coming back to arsenic, I am very happy to tell you that our research shows that there are no interferences from about 100 ppm concentrations from any of these except cerium, which decolorizes the rhodamine B itself. So, cerium is an oxidant, and surfactants also interfere to some extent. So, the details you can have it from the published method. It is available in the literature, and I recommend you to go into details of this method or get in touch with me whenever you need some consultation with for analysis, especially of arsenic in drinking water or any other thing. And now we move on to the determination of residual free chlorine. This is a fairly important method, because free chlorine is usually added as a disinfectant in several wastewater treatments, especially even for municipal wastewater. What people do is they collect river water and pond water, surface waters, and then groundwater. They collect it and then treat it with LM or something like that to precipitate all the dissolved solids, or to precipitate aluminum, iron, etc. Most of the dissolved solids are separated, and then it is treated with chlorine for disinfection. So, normally 0.1 ppm excess chlorine is added to the determination of in the determination method, because chlorine kills the kills the bacteria and other pathogenic microorganisms, and that is why it is a very important parameter for the determination of water quality. Usually a slight excess of chlorine is maintained in drinking water, but the chlorine monitoring is also essential in several other occasions, where wastewater in a city, municipal city wastewater is treated before they let out into the waterways. For example, in Delhi, approximately 20% of water is only being treated before it is let out into Jamuna river. So, remaining 80% we hope that it gets diluted and then concentrations come down below the detection limit. But another application what I always foresee is the small establishments require chlorine determination, especially in swimming pools, etc. And so, in swimming pools, if the chlorine content is high, people get eyes become red, and there will be some slight toxic reactions. Therefore, it is very important that chlorine should be determined. If we do not add chlorine in swimming pool, normally what happens is the chlorine will lead to chlorine will if it is absent, it will the swimming pool water will be contaminated very fast, and you will not be able to swim without treatment. So, most of the swimming pools have got water treatment facility, that is basically a recirculation facility with a dosing of chlorine. So, chlorine is a very important parameter. I want you to note from this slide that it is basically added to kill harmful organic organisms. Excess chlorine can be removed by aeration, but again that is a question of practice, how much we want to retain. Basically chlorine is also corrosive, poisonous, etc., but still we do not have a very viable and cheaper method of disinfection than chlorine. Therefore, it is used in most of the industrial processes and municipality water supplies all over India and world also, all over the world also. The Bureau of Indian Standards prescribes a limit of 0.1 ppm of chlorine. So, this residual free chlorine, normally the chemistry of this reaction is it reacts with N,N-dimethyl paraphenylene diamine, DPD, it is a short to produce a red color. Obviously, all halogens like bromine, iodine, nitrogen trichloride and chlorine dioxide, all these things give this reaction. Oxidized manganese gives the similar reaction. So, we have to assume that all these bromine, iodine, etc., if they are present, they will interfere in the analysis of free chlorine. Since chlorine solutions of exactly known strength are very difficult to make, because you have to dissolve chlorine gas in water, and it is very difficult to prepare solutions of exact strength. So, what we do is we prepare a chlorine solution, and potassium permanganate is used for calibration. So, the absorbance at 515 nanometer is linearly related to the concentration of chlorine. So, reagents, very simple reagents, phosphate buffer, you have to dissolve 6 grams of disodium hydrogen orthophosphate and potassium dihydrogen phosphate, that is the mixture. We have to dissolve it in deionized water, make it to 100 ml. Sometimes we do add 2 drops of toluene or 20 milligram of mercuric chloride in all solutions, inorganic solutions, to prevent the mold growth. So, this is not necessary if you want to add, if you want to determine the chlorine immediately. But if you want to prepare and keep it for use the buffer for long time, then I recommend that you add about 2 drops of toluene or 20 milligram of mercuric chloride to prevent the mold growth. Then other things are very simple, standard potassium permanganate you have to use, and that the details are given here, 0.0891 gram of potassium permanganate, and DPD solution you need, that also I have given you the details. And to prevent interference from the other metal ions, I am recommending here that you use 200 milligram of EDTA while preparing this DPD solution itself. So, you do not have to separate, normally people add EDTA to complex the interfering elements, but here as a precaution I am assuming that you will have water sample from municipality etc., and there will be definitely other metal ions. Therefore, I am recommending that DPD itself can be prepared using this EDTA, and in the reaction mixture EDTA will complex with the metal ions and DPD will be reacting with chlorine. Of course, I do not have to tell you that you have to store it in the dark. DPD is a dark colored solution, and the calibration curve is up to 4 ppm, 4 ml of 10 ppm, that you can use, and you use along with that and add 5 ml of phosphate buffer followed by DPD and dilution etc. as usual 10 ml, and you have to prepare a calibration curve. The calibration curve is not linear. This is a very classic example of a non-linear absorbance relation with the analyte, very classic example, but the results are reproducible. So, we take it that we can use this, but if you fit it with a quadratic equation you will end up with a R square value of about 0.997. So, that is a nice thought, and the recommended volume is 2 ml. So, the cookbook value, if you use 5 microgram of chlorine in 10 ml, that is 5 divided by 10 is 0.5 ppm, that should give you an absorbance of about 0.178 plus or minus 0.01. So, if you go back, you know that the required standard is 0.1 ppm, and we are getting 0.5 ppm should give you 0.178. So, 0.1 should give you approximately 0.03. So, you can take 5 ml. So, that works out to approximately the straight away application of the method within the working standards. Now, here I am showing you one more figure, that is chlorine is determined by the fading of the color, not by addition of the color. So, I have given you a figure here. The fading of the color is not a very convenient, very nice thought, because it keeps on fading, because chlorine is an oxidizing agent. Therefore, we have made a curve or we have established a relationship of absorbance versus time, you can see that the curve, the absorbance is not stable at all. So, you have to fix up the time when you want to measure. Yes, therefore, that time becomes a critical element in the absorption method. So, what we have said here is the absorbance, you keep the time constant between each measurement. For each measurement, you have to maintain the same time gap between the measurement. So, that should take care of the variation in the analysis. I would like to move on to the determination of magnesium. In this I will just give you some sort of introduction, because especially for magnesium, what is important is it is a ubiquitous element, it is a micronutrient, it is present in sea water, it is present in borewell water, it is present in drinking water. Therefore, it is very important that magnesium should be determined. Not that magnesium is having a great problem with metabolism, but magnesium sulphate along with calcium sulphate imparts hardness to the water. So, I think all of you know what is hardness. It is the foaming capability of water. Therefore, if the water is hard, it becomes very difficult to wash the clothes, etc. And many of you, if you are using hard water, you would also notice that on the vessels, etc., there will be scales formation, because magnesium will not go away by washing with water. So, as you keep on washing, the vessels will keep on collecting scales of magnesium sulphate. Therefore, magnesium becomes a tricky element, especially magnesium and calcium. They are most dreaded elements in heat exchangers. Whenever you use a hard water, as the water evaporates, the scales will form, calcium sulphate and magnesium sulphate will form along with the silica present, even if it is in ppm level. Magnesium and calcium will form magnesium silicate and calcium silicate, and as we know, the chemistry of silicates is nothing but the chemistry of cement. So, cement itself is made of calcium and magnesium silicates, and you can imagine we build the buildings with cement. So, it is not easy to destroy cement. It may develop cracks or something like that, that is different, but it is not easy to dissolve calcium and magnesium silicates, and they always form the scales. So, magnesium contributes to the hardness of water. It is an element, essential element for plants and animals. Some magnesium salts are toxic by ingestion, and concentrations greater than 100 ppm. It has there is some evidence of cathartic and diuretic effects. Okay. So, the Bureau of Indian Standards prescribes a limit of 100 ppm relaxable, 10 ppm. It is relaxable up to 100 ppm, where no suitable source of drinking water is available. So, we are presenting you here the Titan yellow method, where magnesium reacts with Titan yellow and sodium hydroxide above pH 12, that gives a red lake. Of course, we should expect that as an alkali and alkaline earth metal, all those metals will interfere. So, in the determination of calcium, magnesium will interfere, and in the determination of magnesium, calcium interferes. So, calcium interference is recorded by enhancement in the absorbance. So, this is overcome by adding calcium. We can add calcium itself to the standards, and the lake absorbance maximum is at 554, that is related to the concentration of magnesium. So, reagents, we include stock magnesium, we prepare stock magnesium 100 ppm and then dilute it to 10 ppm, and then polyvinyl alcohol, again as I have been telling you that we add it to stabilize the precipitate or lake. So, usually 0.1% is more than enough. So, here we dissolve 0.1 gram of polyvinyl alcohol in 25 ml of deionized water, followed by 100 ml of dilution to 100 ml. That also you will have to prepare daily or regularly, on and off, because over a period of time polyvinyl alcohol becomes very thick and you may not be able to pipette out. So, that is a problem. So, we recommend that polyvinyl alcohol should be prepared daily fresh. So, you also need hydroxylamine hydrochloride solution, that is again you can prepare 5%, sodium hydroxide you need 4%, and that is weight by weight, and then titan yellow reagent is 0.15 gram of titan yellow you need, and calcium solution you have to stock is 1000 ppm and you can dilute it, and the working solution should be 10 ppm. So, we will continue our discussion after about in the next class. Thank you.